Hello guys, welcome back to my channel. So today's video is gonna be on an IBESS topic, which is Unit 4. So we're gonna look at Unit 4 4.1 in this video. So I'm gonna be looking at the notes so that you guys can have a quick revision. And that's why you've clicked on this video, because you're gonna revise the topic, and that's what I'm gonna help you guys with. So quick revision is gonna start right now. So let's just begin. So these are the key points or some points that you would just like want to know to be better on your answers. So you have to know these certain facts and stuff. So just a quick thing. 70% percent of the Earth's surface is covered by water. So just a quick point. 2.6% of the water on Earth is fresh water, and 68.7% in glaciers plus ice caps. So 68.7% of the water is in the glaciers and ice caps. 30%, 30.1 you can say is in the groundwater, surface water, and 0.3% is in the surface water, and 97% is salt water. Alright. Now we have the turnover time. So how much time it takes for these to like, you could say recover. Like the recover time, you could consider it as that, right? So oceans take around 37,000 years, ice caps 16,000, groundwater 300 days, river 12 to 20 days, and atmosphere 9 days. Water is renewable in atmosphere and rivers, so you need to know this. Replenishable in groundwater aquifers and non-renewable, remember this, in oceans and ice caps. So we know ice caps are melting, so you should know the fact that this ice caps that are melting is non-renewable. Alright, so now let's just move forward really quick and look at the hydrological cycle. So the hydrological cycle has a few transfers, transformations, and of course we're going to look at the human impact on this water cycle. So first let's see the transfers. So what are the transfers in this? The transfers in this particular cycle, the hydrological cycle, would be flooding, surface runoff. These transfers, it means we've already studied in the previous chapters, but just to like revise you quickly, you need to know it's like it's a particular process in which the particular matter stays in the same state. Same state is the key part. Okay. So, for example, flooding or surface runoff, this liquid water is staying as liquid water, right? So it's the same state. Stream flow and currents, again it's water, so it's water, so you can just say it's in the same state again. Now transformation is the difference between the thing. It just changes the state. In the first one we don't change the state, it's the same. And here it does change the state, so it is maybe from water to liquid, or liquid to water to liquid, no, sorry, liquid to gas, or gas to liquid, or something like that, right? So here we have evapotranspiration, which means liquid to water vapor. Okay, and we have condensation, which is of course water vapor to liquid. Now let's look at the human impact on the water. Withdrawals. So if I look about the withdrawals, let's look at that now. Withdrawals. Why do we withdraw it? Like why do we, what do we take from it? We take water, obviously. So if I say we take water, for what do we take it? We take it obviously for domestic use, right? As people, we discharge what in the water? Pollutants. Changing speed of water flow and where it flows. Of course, we change the speed of water flow by clearing dams, and we could have like canals for like changing the path of water. So of course canals and dams are used to change the speed and the flow, like the direction of flow, or where it flows. These are used. So we also divert river sections to avoid flood damage. Okay, let's just look at that diagram really quickly. So if I look at this diagram, we can right now over here we can see. Give me a second. We can see here we have the clouds and water vapor, water storage and ice. So you can say ice caps. Precipitation is the rain. Radioactive exchange is the energy from the sun. Transport is like condensation. Transport we can take from the movement. It's moving. Evaporation, obviously, we all know, change from water liquid to gas, or we can say over here from liquid to water vapor. Evapotranspiration that we just looked at that right over here. Evapotranspiration, right? Then we have evapotranspiration is just water management. We all know what we do. We use it for like farming, etc. Surface runoff, infiltration. We have percolation, soil moisture. We have a lot of things. The ocean. Let's just remove this for now so that you can understand. Right. So let me just go to the important of it. Then we have the ocean, obviously, river discharge, stream flow, water table, groundwater flow, soil heterogeneity, right? We have all of these, boundary layer and exchange with free atmosphere. So that's all for the diagram. Let's move ahead now. Now, let's look at the examples of changing caused by humans. So we already looked over here. If I show it to y'all. We already looked that there is human impact. Now let's look at the examples of these human impact, right? So we have to know that the changes caused by humans, at least some of them aren't the best. So, for example, Ganges. We know the river Ganges, the Ganges basin. Deforestation over there increases the amount of floods. Flooding increases because precipitation is not absorbed by the vegetation. So I want to draw a diagram to explain this to you because I think this is a very important topic that many of you would want to know but maybe don't understand. I want to explain this to you right now itself. Let me just go there. Yeah, I have a blank sheet for myself to explain. What happens is I'll use different colors for you guys also. So, for example, I have plants over here. Please don't mind my drawing. I'm just gonna do two. So I'll draw two particular diagrams with obviously yeah. And then I have my water, right? My water flowing. Let's say that's the water flow. Okay, so that's the water. Again, I have my water as well in this one as well. Same thing. Now we have precipitation. So we have precipitation. So now we can see that when the rain happens, the roots of these trees may absorb some of the water from this and not lead, and remember what I'm saying, not lead. So there is most of the water which is absorbed by the plants, by the roots. Roots play a great role over here. So roots, just me writing it. So there is no over flooding or overflowing of the river, hence there is no flooding. But what happens over here, because there is no way the water is absorbed, it flows into the river. When it flows into the river, it overflows, hence it causes the rivers to flood. I hope it's clear now. I hope you understood that. So now let's look at the ocean currents. So what is the ocean current? So it's the movement of water horizontally or vertically or and vertically. So how is the water moving horizontally and vertically? So we all know what is surface currents. So now let's move to deep water currents. What is a deep water current? It's caused by the oceanic conveyor belt. Alright? Why does it happen? It happens because of the differences in the water density caused by salt and temperature. So at different places we have different water density, which causes the deep water currents. Warm water holds less salt and is less dense, so it rises. So as I said, salt is one of the components that causes it. So if there is less salt, it means the water density is less, so it can rise up, so it's upwards, right? Water with more salt sinks because it's denser, so it's going down. Alright? When now let's look at the temperature. Water is warm, okay? Cold water has to come and replace it, so it's okay, guys. Has to come up to replace it, which is called the upwellings, which means it's getting up. And cold water rises and it has to be replaced by warm water, which is called downwelling. In this way, water circulates, so it goes either up, down, because of the factors which are salt and temperature. Now, what about the cold currents? Cold currents, we haven't really, you know, been into these currents, but I want to explain them by the equator and pole relation. So, cold currents are from the pole to equator, and warm currents are from the equator to the pole. Okay? So, if I say that's the globe, you know, that's the equator. I'll just write EQ. Okay, that's the equator. That's the North Pole. And that's the South Pole. Okay? When it goes this way or this way, it's called what? The cold currents, because it's coming from the poles, which are cold. So it's coming from the poles, so it's cold, right? It's called cold currents. When it's going away from the equator to the poles, okay, this way, from the equator to the poles, which means equator is hot, or warm, whatever. So that means hot currents or warm currents, right? So Humboldt current is a cold current. It is in Peru. It's or like near Peru, you could say. And Angola current is now example for warm currents, right? So with that, we have come to an end to this 4.1, and I hope you guys understood it. Make sure to like, comment, and subscribe to my channel. Thank you. Bye bye, and have a really nice day.